Well, welcome everyone to the OI conference. This is the data interpretation and artificial intelligence track. And this session now is the remote session for machine learning and remote ops. And I've got three really interesting speakers who are going to present papers today on topics relevant to that. This area has obviously become incredibly interesting given all the changes that have started to happen in our world post-COVID. So the first speaker I've got is Manuel Parente. I've known him for quite some years now and been working with Abyssal trying to get changes to happen in the way we operate. Um, Manuel has been someone who's interested in software since a very young age. He's worked in and around software startups, particularly focused on oil and gas. His company Abyssal was working with many of the top 10 oil and gas companies worldwide. Manuel is actually one of the founders, the chief technology officer, and an inventor holding a patent portfolio on augmented reality and deep learning, particularly around remote operated vehicles. And I know you're going to enjoy his talk today as we move further into this space. Manuel.
Thank you so much for that kind introduction. So I'll just start. The purpose of this presentation is on automatic detection of subsea entities and anomalies in inspection videos. And so essentially, what we're going to talk about is how we use deep learning techniques or machine learning techniques, how artificial intelligence is applied in this context, and what we've done that's innovative in that space. For the people watching this video that don't know much about Abyssal, I'll just give a quick overview. We created tools that digitalize the offshore environment. We go from designing a 3D GIS representation of the environment, so essentially the digital twin of an offshore environment, and then we use that data to simulate and perform simulations and well, for engineering analysis and virtual system integration testing. We then have a component to execute missions, offshore live missions with our augmented reality and digital video recording, which I'll show you a little bit. And then the capture process is how we take data from the offshore site to an online or a cloud infrastructure. And then the focus of this presentation is going to be on the last stage, is after we get the data, what to do with it, how we use machine learning data, and how the resulting data from that processing, how is it contextualized in that digital twin again. So just to give you a small overview, the design stage, we do this on the Abyssal Cloud, which is essentially a web page where there's your digital twin. The digital twin is created in 3D, but also have access to all sorts of live management and remote operations with this infrastructure. With the data available in the cloud, we can then use it to simulate and plan operations before even going offshore. Now that we have the data, uh, we use a physics engine on top to simulate and perform different types of behavior analysis on subsea vehicles. The result from a simulation is a plan, and that plan is then executed. The execution is essentially we have a kit that we install in the ROV control room near or on the vessel or on an unmanned surface vessel equipped with an ROV. And what it does is allow the better data management of the locally offshore. If there's a pilot there, we also do augmented reality to help the pilot navigate better in low visibility conditions. This is an example of that augmented reality. Because we have access to that 3D environment and the live telemetry from the ROV, we can do things like this. This is just a couple of pictures on the system in use. Now that while we're performing those operations, those jobs offshore, and because we're sending that information to the cloud, our capability of creating command centers on the fly is very straightforward for us to do. Um, this is an example of what we've done, and Al was also involved in this. This was, we were tasked with the monitoring of an operation where an unmanned surface vessel equipped with an ROV was doing an operation. So essentially what we've done, we've set up a command center in Sunbury in their headquarters for BP. And then we use the cloud to disseminate that information live to Baku and Houston, so that people could see the operation in 3D live. So, but let's dive into the process and contextualization. The purpose of this presentation is how can we accelerate the analysis of inspection videos and by subject matter experts. And this is all done by automatically detecting those subsea entities and anomalies, the exact job that the subject matter experts do. And this was our motivation. The manual or human analysis is always error prone, obviously time consuming, and you have to parallelize with human resources. What we present here is a method that relies on weakly supervised deep learning models. Essentially is how can we train a model with little human intervention in the process of training that specific model. So in order to explain what we do really good is how to do it normally. So normally an AI works like this. Our objective is to say or automatically identify if in an image there is or isn't marine growth. And this is the example we're going to use throughout the presentation. So if you input two data sets into a deep learning model or a convolutional neural network, the model will say a prediction, and that prediction is true for the top image and true for the bottom image. But when you validate those results, you will against a ground truth, you will have a positive result and a negative result. So this is negative reinforcement to the neural network, and this is positive reinforcement. This is how usually the deep learning models work. Now let's say that we want to not only know if there is or isn't marine growth, but also to know where it is on the image. And for that, the biggest problem with this kind of objective is that the training is very time consuming. The subject matter experts have to train the data, and they have to say, we have to annotate every single image that's used for training with bounding boxes. So we've developed a method to do it differently and much faster. So in this case, if we put inputs to different data images, obviously there's a prediction from a model, then the comparison will do the positive reinforcement. But let's do this without, and this is our objective, how can we detect any anomaly, in this case marine growth, without annotating bounding boxes? So the objective here is that the subject matter experts only have to say yes or no to an image, if there is or isn't, and then we want an AI to say where it is. And the way we've developed that technique is with a method called weakly supervised learning, which counterintuitively is not weak at all. So essentially is, instead of feeding an image, the first thing we do to an input data is to split the image into smaller images, and the model predicts yes or no to each one of those single splitted images. And then the trick is using a max pooling function. What it does is very simple. If there isn't any of those single images in which the model says let me just rephrase this. If the ground truth says that there isn't any marine growth, then all the splitted images that will go then to the deep learning model will be selected as there isn't any marine growth. the max pooling function does this. If there is a single mini image that has a marine growth, we consider all of the image as true, and it has it has marine growth. So what it does is this: every time there is an image that we say it's true, and the model finds one piece of imagery that is also true, it will be reinforced. So the result is this: when we take an image, all the single smaller images will be selected as statistically more probable of having marine growth. So we then segment it so much that we can create an areas of that higher probability of marine growth by reinforcement of that deep learning. And the only thing the human needs to do is say yes or no to imagery. Which is much faster than analyzing where it is. But the result is that by using a Gaussian and color mapping, we can create a probability cloud of where that marine growth is. Let me just put it into context. What we're, and actually the classification results are 95% overall accuracy. What you see there in post-process is our because we've done an update on the model, is that because if the earlier frames, if we're analyzing a frame and the previous 5 seconds have a high probability of having marine growth, then the other frames are also probabilistic more positive to have marine growth. So we use a post-processing a time-based smoothing on this. But let's say detection results on this kind of imagery. These are a few of the results from subsea entities to pipelines, marine growth in several different situations, but also to detect other things. To detect, it's specifically useful to detect the ROV when we're talking about imagery, because we can remove the manipulator from a model that we're trying not to have something in front of us. If we want to analyze only the image, we can take out the manipulator in front of the camera. But let's say that we now have a probability cloud. If we can select, instead of having a color grading, we can make it binary. Either there is or isn't marine growth in that area. We can segment, and then we can create segmentation masks, meaning that we know in the imagery where that structure is positively or negatively. And this is going to make sense when we're moving to use cases. But the overall result of this weakly supervised deep learning model is that not only the annotation is faster, it's 100 times faster to annotate data like this. The actual model itself is also 2 times faster than a traditional deep learning method, which means that this could be the difference between this technique may present itself as the difference between not being able to do it in real time to be able to do it in real time. That's the benefit. But let me just put this all into context on real use cases. So the objective with the Abyssal AI initiative is always to understand data, to reconstruct, and to contextualize. And I'll give you a few examples of how we do this. So by using the Abyssal Cloud, in which we have a huge library of videos, we can also, what we're trying to do is to extract. The first thing we do is extract metadata from video, so that we can begin to organize videos and select them more easier. So instead of training an AI model with all kinds of different imagery, we've only focused on what's really important for that specific use case. And that's only achievable if we can query all the data, if we can organize it into areas of operation, into types of work. Let's say that another example is the work that we've done for a client. This is the analysis of integrity threat detection in pipeline inspections. Essentially, it's the coding on a pipeline joint, and if there is or isn't integrity threats. But not only did we do that with 98% accuracy, we did that with very little images for training, and we could also segment where that integrity threat is. So green is where that integrity threat is. A few other examples is how can we understand things on screen. So understand that if there is a structure, if there is a text, let's take this example of a text on a structure. If we can pinpoint this specific PNID, we can trace back this image on this day with an asset integrity management service. Other examples is finding sacrificial anodes. So think about analyzing a year worth of operations and find out where all the sacrificial anodes are on screen and geographically, which I'll show you next. But let's dive into fish. We also did a work in fish classification. This is, we trained it with so many images that the AI model began to be much better than humans in predicting fish on screen. So watch this is a game we're gonna do with the audience. This is you against the AI, and I'll play the video. And whenever you find the fish before the AI, you'll probably win a prize, which is because it's going to be very difficult. So the AI will begin giving you a probability cloud on top of the video, and now it already found a fish. And you'll begin seeing the fish there, because the AI will not only it relies on previous knowledge, and that knowledge is that not only there's a probability of being a fish because I can identify a fish on screen, but also because of the area of operation, the colors, the situation is also a factor in the analysis. Obviously, this is a biased use case of AI being faster. Normally, an AI will be as fast as a human on a normal case, but there are situations where it's much faster than humans. And we took this problem because identifying a yellow structure on a black background is somewhat easy. Identifying fish with all different shapes and sizes and colors, it's an even difficult problem. It's an even more difficult problem to solve. So it allows us to develop the technology much better. And how we were able to achieve this. Let me just rephrase this. Not only could we were able to identify things on screen, but we decided to be able to identify depth on screen. So having depth perception. So what we did, we used our simulator to feed an AI with synthetic imagery, the semantic segmentation, which is perfectly annotated data and automatic, so free, and provide that AI with depth perception. So that means that we are feeding an AI with synthetic imagery, which is free, no human intervention, and allowing an AI to begin reconstructing any video because it knows how to perceive depth. And for my few last slides, because you can perceive depth, now you can volumetrically reconstruct. And what we've done was, this is actually a volumetric reconstruction based on video. Legacy video, it doesn't have to be a special camera. So let's say this is what you see on screen is actually 2 different years of the same plat, but because there was a pipeline walking issue, it moved throughout those 4 years. So these are actually 2 point clouds from 1 year and then from another. This is the same plat head. So what we were able to achieve was an accuracy of half an inch. So we have half an inch of accuracy in the volumetric reconstruction, and the result from one is something like this from a video. But this is just the result. Let's see it in a real use case. This is what we've done for a client, and what we had was only this real footage. What we were able to do with this footage is to volumetrically reconstruct in a point cloud So essentially, this is the point cloud from this imagery, and then we compare it with the CAD schematic. The difference between the point cloud and the CAD schematic is actually the marine growth, but now in a volumetric response. So now we automatically can find out the thickness of the marine growth purely based on video and CAD schematics. But not only were we able to do that, but we were also able to estimate the position of the ROV, so essentially reconstructing the operation and the movement of the ROV, but also to estimate the camera movement, which is essential to do this. So the way we do this is in the Abyssal Cloud. If you want to do that to your videos, this is the product that we use. My last slide is on what we're developing next. And what we're developing next is Subsea.ai, which is the capability of you as a user to create your own machine learning models based on our techniques. So we've developed our own techniques of developing machine learning models, and we allow you to do that exactly that with your own data to fix your own problems or your specific problems. So last slide. Thank you very much. I'm looking forward to any questions that you may have.
Thank you, Manuel. I will. I've got a lot of questions, but we're going to hold the questions back for the end of the session when we've got a round table, if that's okay. So I'm going to invite Trevor to give his talk now. So Trevor also went to Imperial a little bit before me, but has seen masses of the North Sea and other regions develop over the last few years. It's a geophysical and geotechnical background in ROV surveys. Sorry, I've got a little visitor here. Right, Taylor, where do you go? He's also doing outer straightness surveys and small piece metrology. In recent years, he's working with the UTC survey, focusing on Gavia AUV and the development and automation of remote services. Now, Trevor's talk today isn't about the equipment for all of the things I've just mentioned, but something that's much more interesting, I think, as we move into this change, and that's how we deal with people and the new ways of working and how we use this transformation, because we all see technologies come through and then they just sort of fizzle out because we don't get to the implementation and changing how companies use it and get the value out and drive it through the business. So over to you, Trevor.
Okay, thank you. I'll just share my screen, technology permitting. Right, so you should all see that. Yeah, so we're focusing not on technology, not on equipment, not on software, but on people. And it has to be said, what I'm going to argue is that remote services, automation, is a negative impact on the surveying profession. So nothing personal to any company or other presenters, but we're just going to argue through this. All right, so it's all about demanning, reducing the offshore headcount. Right, and that's not just in survey, it's in the engine room, on the bridge, everywhere is wanting to automate and remote control. Right, and everyone sort of can go, oh, you can't do it in my particular discipline, but there's a big pressure from on high to just get remote and automation into the business. And the arguments, it's obvious, reduced offshore headcount, fewer man movements, you can bring an expert to bear onto many spreads rather than needing an expert on each spread, and all of that's going to reduce costs. Right, so what's not to like? Well, that's what we're going to discuss. So by removing people from the work site, one of the key things we lose is what I call situational awareness. Now this is peripheral knowledge beyond the sensor displays. It's not about giving the remote surveyor more cameras so they can see what's happening outside. It's the fact that if you move an online surveyor to a remote location, he's no longer in the mess room hearing what's gone on elsewhere or on previous shift. Right? So he just misses out on the accidental conversation. That's a big problem with remote services. Also, if we're taking people, demanning the offshore spreads and putting people in remote control centers, operating automated software, we're dehumanizing the profession. You know, I made some of the best friends of my life working with people offshore, where you're on a big tin can for a couple of months and you get to know people, and that really strengthens networks when you come onshore as later in your career. So putting people in remote ops centers with automated software just kills that growth of a teamwork and the ability to learn from your superiors offshore, which is going to make the attractiveness of a career in surveying going to decrease, in my opinion. So let's look at some of these remote services. Remote data processing, that's probably the easiest in terms of the technical issues. Right? We just beam the data ashore and a data processor can do it there. Right? Now, so we're just going to move an offshore data processor to an onshore location, or we're going to recruit a different type of person. Does a data processor need to have had offshore experience or exposure to the acquisition of the data for him to be a good processor? Now we can automate the processing, right? So then you go, okay, so now I don't need as much skill and experience because the machine's doing it all for me. It's recognizing features, it's processing data much quicker than a human can do it. Right, so you go, okay, well then I could put that automation still offshore, so have fewer people offshore, but that person doing the processing offshore would get the benefit of being involved with the acquisition as well. And I think we're losing our way sometimes in concentrating on getting everything onshore. And we should maybe look at also how we can just automate and keep some people offshore. The more difficult one is remote control of data acquisition. Now, the base case is let's just take an offshore surveyor and give him a whole heap of displays and communication systems where he can do it remotely. Right now, obviously missing out on the situational awareness, but we've covered that. So the surveyor, he can still work a 12-hour shift, right, paid as if he's going offshore, but now he's sitting onshore. Now it's quite tiring to do a 12-hour shift onshore. I'll ask a nurse or a doctor, but it's possible. But again, it's not an attractive move. If you've been used to working offshore with all your meals and everything provided, gyms and all the rest of it at the end of your shift, and you're now coming onshore, working in a box and then going home, less attractive. Also, the reason we're doing this is to reduce the offshore headcount, save money in the end. Now, the one way for this one-for-one shift, then if you pay as you go basis, so the client is not paying for the surveyor when there's weather downtime or in transit, or even where he's waiting for his particular task to come along, then so the client gets a win, right? But presumably we're going to pay the surveyor only when he's working. So now instead of him getting a month's offshore pay, right, he might only be paid for 3 weeks because he's not having to travel and transit and all the rest of it. So that's not good for the surveyor. And then really, before you can get the big savings, is where we can automate the monitoring. So one remote surveyor can run more than one vessel. Now you need to have a sort of critical mass for this to work, so that Sod's law, if 2 of his vessels need intervention at the same time, he can have a colleague come across and help him. But if you're automating the monitoring, then you're sort of de-skilling as well as demanning. So instead of 1 surveyor per vessel, we might now have 1 monitor looking after 3 vessels, and perhaps just calling in an assistant, a floating assistant, to help him with any problems. Now, if you've automated the monitoring, you're now just waiting for something to go red. That means you have to intervene. Right? So we don't really need a remote surveyor to be experienced. In fact, does the remote surveyor that's doing this monitoring need to be a human? It can be basically a chatbot that is looking for something to go red and then sending out an automated response. Have you read the manual? Which is often the first response that you get from a human help desk. And it's only then when the offshore user goes, yeah, I've read the manual, it's still not working, that your case elevates to a human expert that can support you. So even fewer people. And you can almost, and do they need to be surveyors? Right, so then you've got, never mind the online surveyor, let's look at the role of the experts. So everyone sort of talks about, oh yes, remote services, let's, your team of onshore experts support many jobs. And you go, that's much more efficient than having an expert on each job, and also addresses the skills shortage, where all these experts come from. So you go out on a metrology and you haven't got the best metrology man because he's busy on another job. So now we can bring the best metrology man to every metrology, right? Because he's sitting on shore. So what happens to all these other lesser experts that you're no longer needed? Right? What are they going to do? If they're not getting the day's work, then they've got to retrain as something else in the survey industry, or just leave. Right? And then you can apply the same to inspection coordinators, right? That one coordinator could supervise multiple inspection engineers, right? And same with party chief, offshore managers, client reps. Do they need to be on the boat? Can they just be sent all the screens and data so that they can QC and monitor from onshore? And again, you don't need a client rep on a remote client rep per vessel. One client rep remotely can QC multiple vessels. So fewer people, you're decreasing the pool of personnel in the industry, which is decreasing your experience and expertise that's available. Now the converse is that you keep the experts offshore, so they've got all the situational awareness and ability to intervene when things go slightly wrong, right? But you have the surveyors onshore working remotely. So you could reverse this, but you're still separating the experts from the troops, which means that you're not really getting the succession planning, the training that an expert can give to the rest of his team. Right, so that, will this automation standardization is going to kill problem solving? If we haven't got people offshore and everything's nicely automated, standardized, we don't have to solve a problem, and which then leads to some development of a new technique. And then if we've got people leaving the industry, will we just lose capability, capacity, new people coming through with new ideas? Then local content. We've all seen contracts where you're required to have use local based personnel, and that's to increase the capacity of that country, to increase employment and to increase the capacity of that country to do the work themselves. So remote is exactly the opposite of that. So how do we address local content with remote services? Then if we're needing monitors, rather than operators of software, do we need to have graduate surveyors? Right? Are we telling academia what we want from the next generation of graduates? Do we want more programmers and data analysts and less hydrographic surveyors? How many online surveys and data processors will we need when we've fully automated the industry? Like, do we want to recruit graduates, or do we just want to have apprentices that we can train to operate the software? They don't really need to understand what they're doing because we've written some very clever software that does it for them. Are we talking to academia? I don't think we are. So my conclusions. Right, so we can't stop automation. We can't stop remote services. It's going to happen, right, because it's producing savings to our clients and survey companies. Right, now, but we have to temper that. Right, not every job is suitable for remote, to be done remotely. And we've got to sort of pick up on, not be dazzled by the technology, but instead pick and choose when we apply the technology. And it needs client commitment. We can't just have remote services waiting for the client to say, yes, I'll have it for one day. It needs to be a sort of total commitment to do it when relevant. And then back to the people. Right, I think I've argued, I hope, that all this automation, standardization, remote saves money, but it's at the expense of the workforce. And we have to think of the impact on the workforce, both in mental health and in income, of what's going to happen to the workforce as we go into the remote services that we've all been talking about, and we're seeing major steps. So that's my presentation, different from what I normally do. And I look forward to some questions at the end from my peers. And
thank you, Trevor. That's great. Some really good questions that you raised and comments. And I've written a whole load of notes, so I'm sure we'll have a very lively discussion in the roundtable shortly. So thank you. So Chad Collett is our third and final speaker. So Chad has an unusual background in that he comes from an interesting part of the world on the east coast of Canada, and is the son of a fisherman in Newfoundland. But he also is a diver and has completed an electronics engineering technology degree at college. He founded his own company in his basement, so like a proper startup story, and has grown that company now to 25 people, and they service 140 organizations in 30 countries, so a true growth story. And he, as we were just talking before, is a really interesting niche in that he's helping all of the people who are collecting data, categorize it and use it, or get it prepared for automation, which means that the companies who want to do machine learning, machine vision, and can be more successful. So Chad, over to you.
Thanks, Al. That was really kind.
You're welcome.
I couldn't say it that way myself, but that was great. All right, so hi everyone. So I'm going to be talking about scripting in the subsea. So using scripting to reduce autonomous system complexity and cost. So it's quite relevant for this time slot, which is why we're all here. So first, we're going to go over a company overview, a little bit about subsea. Then we're going to talk about what is scripting and why would you script, with a live product demonstration, and then what are the benefits with some real world examples and videos, and a little sneak peek into a new real-time streaming service we're working on. Subsea Imaging develops advanced camera and video solutions, and thanks to our focus on reliability, modular design, and dedicated after-sales service, when a customer decides to use a subsea camera, they can be confident that we are committed to your success. With years of experience in our field, we're able to easily navigate meticulous evaluation process that businesses and researchers must adhere to when picking who to work with. Our customers do not choose their partners lightly because of the long-term a long-term equipment investment. Here's a global snapshot of some of our customers. We have over 160 clients who operate in every ocean on the planet. So enough about that. Onto what we actually are for. What is scripting? Scripting is a simple software language that, in this case, allows the solution to run autonomously. Scripting uses the Subsea open source API, our scripting, which runs inside the camera, and the camera is an embedded system. The user writes scripts referencing the Subsea API to complete their desired functionality. Subsea has created examples of scripts which can help with advanced applications. The API has conditional statements that allow users to execute commands based on the state of other input variables such as time or external sensors. There are also two time sources available, the built-in real-time clock and external network time protocol. So this is a script line here, which uses system time. And when the system time modulus 5 equals 0, it takes a picture. So what this means is every 5 minutes, there's a photo. It's a time lapse, simple time lapse script line. What we're showing in this graphic is the idea of sensor fusion. So all of your data comes together to create an accurate picture of the environment. Subsea cameras are data loggers, and that data can be used for scripting in real time with conditional statements. So most NMEA format sensors can also be logged, including depth, altimeter, and CTD. So in this little script line, you can see when the depth is greater than 5, it can start logging. It's another simple script line that can help with automation. The API allows the user to control external sensors directly. The aux ports of our cameras interact with components via RS-485 and TTL signals. These couple API lines here, you can see we're setting the device on aux0 to an Ikoria Mark III and the device on aux1 to a Manta Ray. Why would you script? So in an application where there are periods of time where user interaction would be inefficient or isn't possible. So common applications where there wouldn't be human interaction would be AUV, observatory, or other battery deployed scenarios where a time lapse of stills and video are required. Subsea cameras can control white LEDs, far red, and other colors of LEDs, as well as different types of lasers. The camera supplies power and strobes the LED in sync with the sensor exposure time. This reduces equipment and interface complexity. So you can see their API call for enable strobe. And Subsea has a number of plug and play options for lasers. So there are many lens options for different machine vision applications, including line, grid, and parallel points. So laser brightness of 100, would turn on your laser at 100%. Now I'll give a real-time demonstration of a camera with scripting capability. So you can see the camera running here along the top. Here we have our heading, tilt, and roll. You can also have a depth sensor integrated, strobe control to turn on and off your strobe, and exposure control so you can change your exposure bias. For auto exposure, you can also set it to manual exposure and adjust your ISO and your shutter speed. You can also control your focus from near to far, and everything can be full auto or full manual. Along the left, we've got some recording settings. So you can have different site names. So site 1, for example, and you can have a project name or a folder or directory name. So project 2, and we can also insert some tags, just simple tagging structures to make things a little easier. You can get down to milliseconds with tags, and you can also have custom tagging. Quality can be recorded from 4K to SD, and I'll go 4K, and we can also record H.265, which is a new codec over the last number of years. H.265 is about double the quality for the equivalent bit rate. So if you're recording at 100 megabits per second in 4K or HD with H.265, you'll get better quality. Similar with digital stills, we have a folder naming convention. We also have file naming convention that mirrors the recording. You can change from RAW to JPEG, And you can also take digital stills continuously. So if I set it to 2 Hertz and hold down the button, you can take digital stills rapidly over a wide area and use those digital stills then for photogrammetry or other applications. You can change your white balance as well. So we can have a shallow water setting. Say if you were in shallow water and there was a lot of green, you could reduce that and adjust it for your environment to get a better image. There's similar to that theme, there's an image enhancement built in if you really can't see anything. That's for really murky environments. This is a tool so that you can at least see something to get the job done. You can also view our images and data in real time, and other computers and processing systems can access this data over Ethernet from the camera in real time. So you can record, you can have it on observatory or an AUV or something with low bandwidth connection for video. So you don't need your live 4K back. You can record to the camera or take digital stills, download those images and video in real time, process them, and you can get very creative with your workflows to improve efficiency. NAS storage as well, so you can store to an external NAS on the network, somewhere on board the vessel. And data logging. So it's enabled right now. We can change our logging frequency, and that's in Hertz. And we can start and stop. We can also reset the IMU or set a new 0 for the IMU. That's your heading, tilt, and roll. So I'm going to reset it. And you can control your attached lamps and lasers and other devices that you have connected. On the right-hand side in the advanced settings is where we're going to be focusing just some quick communication connections, settings for bit rates of the live video. Here it's important to understand your time and locale settings. Time is really important for data logging. So you've got your region, your time zone, it defaults to UTC, and you can also have network time. So that would sync to an online cloud NTP server, one on board a vessel, or one even in the system, say in the case of an AUV. And you've got a local date and time, which the camera will default to if you lose your network time connection. Some diagnostic information. And this is where you set up your plug and play auxiliary devices. So you can have a number of devices here. This is what we currently support, and we can add more over time. Right now we have an Akoria Mark III and a Manta Ray parallel laser connected. And as you add devices, the controls are accessible through the API and through the user interface here. This is the point of having this demo right now, scripting. So I'm going to run this script. And what this will do is set up a stop motion function. So it's changing it to raw format images, turning on auto exposure, autofocus. Should wait for 2 seconds now. And it's going to turn on manual focus to lock it in. Manual exposure to set the shutter speed and the ISO. And what this function will do is repeat, take a picture, wait for 2 seconds, take another picture, and then wait another 10 minutes. So that function will continue to run autonomously now. You can see a script is running through the user interface. You do not, that's something to note. You do not need to use the user interface with our cameras. We have customers that are using Python scripts and other scripts to using our API, sending commands to the camera, as using the camera as a I guess a sensor as a part of a larger system. If you would like to cancel your script, you can just turn it off this way, and that icon disappears. So now I'll write a quick demonstration script. And we can add some comments, some notes, and I'll set it to auto exposure, video name, test, and update white balance, auto, and lamp brightness 100, and start recording. And I can also have this script execute on start. So what that does is when the camera boots up, it will automatically execute that script on boot up every time the camera turns on. And there we go. So what this means for researchers and for people in the offshore and on any underwater application where you need imaging is a lot of this stuff has to be usually designed or figured out by the researcher or by the industry person, by the professional. We are working hard to try and automate things and try to make it really easy. So that's the camera demonstration. And we go back to the presentation now. So what are the benefits of scripting? It's reduced autonomous system complexity and cost. Scripting allows the camera to operate independently without requiring an additional computer or person to send commands on a schedule. For example, in an observatory, there would be a dedicated server running Python scripts or other scripts to directly control the camera node and the other sensor nodes. Normally, underwater imaging solutions would require a separate data logger. In our case, the camera is a NMEA data logger, so that reduces equipment. The camera has 512 gigabytes of solid state storage and records weeks of NMEA formatted data, days of video, and tens of thousands of images. Each additional piece of underwater equipment would require its own pressure housing and cable. So by reducing components such as data loggers and controlling systems, you reduce the cost and you increase the reliability. And when a system also has less components, you would also expect it to consume less power from battery systems. So I'm just going to show you a few real world examples. So Subsea has been working with the OOI, Ocean Observatories Initiative in Washington State for a long time now. So this is a video. This is a video at the Axial Seamount. It's several hundred kilometers off of Washington State. They've been using our cameras for a long-term time lapse of images and video of a hydrothermal vent. The OOI is a very large networked infrastructure of hundreds of different sensors at different sensor nodes. They're all connected with a large fiber optic network back to a giant server station at the University of Washington's Applied Physics Laboratory. This particular hydrothermal event has been studied since 2014 with subsea cameras. It's called the Mushroom, and the hot spring fluids can reach temperatures, very high temperatures. The creatures that reside there, living on this structure, shift and change over time. Different populations go up and down as time goes forward, and the vent structure itself changes shape as well. So it's a very interesting study over a very long duration. So if you'd like to know more about that, you can see more on our site or on the OOI site. One second. Okay. There we go. Okay, trying to figure out how to use these slides. All right, so this option was developed with the Ocean Observatory Initiative on the West Coast of the United States. It turns the camera into an Ethernet multiplexer for 4 devices with a resettable circuit breaker and fault detection. So this is another piece of automation. Essentially, it reduced the need for having a separate Ethernet switch with relays and fault detection, and we moved everything into the camera so that the camera was the hub, and we could automatically detect faults from under voltage, over voltage, or short circuit from other equipment. So we had a pan tilt, 2 LEDs, and a set of parallel lasers all running from the camera, and the camera was the hub for that. And everything was accessible through the API for scripting. The Marine Institute in Newfoundland has been using subsea cameras with scripting and intervalometer for many scientific studies. Their system runs on batteries and attached to a lift wire. The systems are deployed between 100 meters to 3,000 meters on these lift wires, and it's all autonomous. So the cameras are programmed before deployment on the deck of the ships. The operator doesn't have a real-time view of the footage, and it goes along and it hits rocks and does other things, but it's quite robust because it's a heavy steel frame running on batteries. The system is used in fishery studies to add data for stock assessments. In this set of clips, the Marine Institute was conducting a turbot fish study. So the same deployment methods have also been used to study Greenland sharks and other species. Here you can see Subsea's new towed camera solution being tested in the world's largest flume tank at the Marine Institute in Newfoundland. You can see a digital still script running as the LED strobes in sync with the Rayfin camera. You'll notice the green dots on the bottom of the tank as the manta ray parallel lasers are activated. The dots are calibrated at 10 centimeter spacing and can be used for scale and range. With this system, a live view is available, so scripting is not 100% necessary, but it's definitely useful for automation. So an example of this would be if you wanted the system to automatically start recording at a certain depth, you could do that, and that takes some of the guesswork out of it. University of Victoria has been using Subsea's observatory solution for their underwater study in Barkley Canyon since 2014. And in May 2014, 3 humpback whale rib sections, 1 block of Douglas fir, and a block of orthogenetic carbonate were placed at a depth of 890 meters inside Barkley Canyon at a site on Ocean Networks Canada's Neptune Subsea Camera Observatory. Purpose of this experiment is to monitor the changes triggered by the implantation of various organic and inorganic substrates, as well as to monitor how benthic creatures utilize the sparse food resources available in deep sea settings. So on a schedule of every 2 hours, the autonomous subsea cameras and the LEDs, they panned to 3 different substrates while holding position for 1 minute each, and they captured 5-minute videos over 6 years. And the study is still continuing today. So it's a small kind of hotbed of activity for creatures because the abyssal plain is pretty sparse. So this site is kind of attracts species from a wide area. In the webinar theme of remote operation and the new normal, we thought it would be relevant to give a quick overview of the new Subsea real-time streaming service as well. It enables remote operation of assets. So kind of counter to our previous friend. We are enabling that. Our hands are off from there. We're enabling the service. We don't decide whether you want to use it. So this service enables remote operation of assets and allows decision makers to access live video from anywhere in the world. So here's how it works. The streaming solution sends offshore video sources to a cloud server. From the cloud server, your video feeds are sent to your secure Subsea streaming account. From anywhere in the world, your account manager can log in to set up live video presentations. And you can then send your presentation secure access code via email. So, because security is paramount, you can send that secure access code to your clients and your coworkers who need to be in on it. Offshore real-time streaming allows everyone inside your operation to connect through a low latency, high quality video feed with audio and data feeds coming soon. So each presentation can have 4 low latency video sources and multiple viewers at the same time. Our streaming solution offers secure HD offshore streaming with flexible bandwidth, frame rate and quality, and a measured latency of actually less than 1 second. It's also a cloud-based software that can be downloaded onto any PC, and it's compatible with all camera standards. So there's no additional hardware required, and all you need is an internet connection on a Windows PC. We're offering a free 30 days right now, so it's very easy to get started. And if you're interested, you can email team@Subsea. We are here to help with your remote operations. So in conclusion, most Subsea projects require many components. Integration of these components can lead to high costs and complexity. Scripting reduces those complexities and costs, and it can save time while also increasing reliability. Subsea has a number of well-designed solutions that can be easily adapted to your requirements. And if you're interested in learning more about Subsea and our solutions, our qualified team is here to help with your application. Check out our website, subseaimaging.com, for more, and thank you.
Thank you, Chad. There's a lot of interesting technologies coming through and bringing them to integrate. And I think the thing that's most interesting from your talk is how you integrating across different sectors, right? Different industries. So, you know, you can see like what we're learning from environmental and the science guys is pushing us forward. And I know I've done quite a lot of work on the autonomous machines bit, and you can see, you know, that they're pushing us to smaller and cheaper, which, you know, changes how we're able to work. So it's very interesting to see what those guys have been doing for multiple years, right?
Absolutely, yeah.
Okay, all right. So I'm going to host a little round table now. So I don't know if Trevor and Manuel, if you want to come off mute, just see if everyone's there. Right. So I think maybe a good place to start then would be Manuel. If we go back to you, I obviously I've been interested in what you've been doing for some time. And I saw the accuracy of some of the offers you have with your case studies is getting pretty close to 99% now. And I'm wondering if that's, you know, that's kind of the point now where this flips over and we see in 2021, you know, the much broader adoption of machine learning now in subsea inspection.
Well, yes, we're very much close to. It was about 3 years ago then that there was a threshold in machine learning, and that's where machine learning became faster in understanding things on screen than humans did. It was about 2 or 3 years ago that threshold, and now we are there in terms of technology, and that's it. We have to understand that it's for certain situations. We need to understand what the KPIs or the success factor is for a certain scope, so we can achieve a high degree of accuracy there. But yeah, the tools that we have available now are super helpful in it.
Okay, no, and I think this goes into what you were saying, Trevor. So I see it as kind of automating tasks rather than jobs, and a kind of restacking of jobs. And as the crew change continues to happen, probably the people who are coming in, you know, are going to come in with different ideas and expectations. And
it's on the automated event recognition, then I can make a point that you know, with human inspectors, the industry has got very used to and has processes to capture the fact that humans get bored, make mistakes, etc. So we have competency schemes, we have training, we have checking processes. Right, at the moment, we don't have a competency scheme for a machine learning system.
I couldn't agree with you more. I'll come back to that in a second because I just totally with you on that bit. I was just wondering about whether you also see that probably you know, that the change will just sort of get managed, and as people come in that with different ideas and different skills and maybe dual careers because they're, you know, buying a house and that, and people aren't maybe as tolerant of just disappearing off for a month at a time, that it might somewhat balance itself out. It's a change that needs to be managed. I think that's the point I sort of, and that maybe actually the skills will change. I mean, by the time I got to Imperial, we weren't using slide rules, and I'm guessing you might have missed them too. But there would have been people, you know, who have retired recently who would have started out with those and you know, went on to spreadsheets and so I my underlying belief is that it fits sort of that change, and it is painful, and we need to take people with us, but it's just because I suppose the biggest thing to say is, yeah, it does save money, but actually the other thing it does, it takes people out of harm's way, and it reduces our carbon footprint.
Yeah.
If done well, and I see that as sort, and I don't, and the thing is, I see this as like this. I imagine that we're going to use a lot more smaller machines, you know, with more sensors, and it becomes more like surveillance instead of inspection, and actually the demand for processing data actually goes up, and so that also sort of balances itself out. So yes, there's maybe less people offshore and they're only doing the critical jobs, but the people who either come onshore or come into the industry taking on these more automated tasks actually work on the more interesting stuff. And so, you know, it sort of can get managed even if it's a bit bumpy along the way.
But that's where we need to feed back to academia
Yes, I agree.
what people we need 5 years from now.
Yeah, I don't doubt that. I don't doubt
Well,
that. So I think it's just a changing of the skills rather than a de-skilling. Although I recognise, because I started out in the steel industry, you know, they lost skills as they went along and things changed, right? So the new skills became more valued in different areas. But it's a difficult one, but I can see your point.
And if you regarding about the machine learning accuracy, there's one thing that we can't put on the same basket as other technologies. There are technologies that can be ambiguous in their success, but machine
That's
learning
true.
is not ambiguous at all. You can mathematically prove an accuracy of the AI model that you are currently running. When I say it's 98% accurate, it's on the data set that was given to train. So if a client that has that data set and we train the model with that data set, it can keep a clean data set that we don't have access to and use that to mathematically prove the accuracy. So it's not in terms of that helps in a competency scheme differently from other technologies because of that. And that's why I think that machine learning will be easily adapted because even in an industry that's a little bit not keen into adapting to new technology, I believe that the specific case for machine learning is where that the adoption rate is all over the world exponential. And regarding the I'm obviously sensitive to the impact of on the workforce, but I'm also profoundly pro automation.
Yeah, I feel quite similar, Emmanuel. I think every big change there is a really difficult job to do it properly, but actually there will be more interesting jobs on the other side, and it's trying to do it in a proper sensitive way rather than doing it chaotically, right?
I'll give you an example. You remind me when you talked about slide rules, and the term computer is actually from the 17th century, and it was only after World War II then we were using human computers. That was what we called, and then Alan Turing came along, and then we had the first computer. And what the first the latest human computers were actually doing calculations for space exploration to missile trajectories, and they adapted to becoming programmers. And an interesting fact is that the world's first professional computer programmers were actually women, and people like Betty Snyder or Betty Jean Jennings. They went from using slide rules and be a computer to be a programmer. So it's always a change of an adaptability that we need to have in terms of changing the core competencies of surveyors. That's what I think. I think there needs to be, but we need to be sensitive to the fact that that is a problem. That's where I agree with Trevor.
And that's cool. And you know what I wrote down, Trevor? I wrote down it's like this is actually common to all of our professions.
Oh, indeed.
So,
yes.
so what
it's not
you
just surveying, it's the steel industry.
It's everything. But even just in our little industry, I mean, it's all of the tech, all the engineering disciplines, whether onshore or offshore, are all on that same journey about trying to reinvent without losing too much along the way and leaving space for the new to come in. I also like your question because I always worry about this too, about does standardization kill innovation? And I look at like the most successful example, one of the most successful examples is probably 3M or Toyota, and Toyota's a good one for us because they build these great big factories that are similar scale to what we're used to dealing with. and they have managed to sustain that culture of innovation while remaining mostly standard. But I do agree, you have to keep one eye on that just doing this as a one and done and you pour the concrete in and that's set forever is a surefire way to fail too, because you're not responding to the world as it's changing, and it continues to change, right? So I thought that was a really good point as well. And I know, you know, with some of the things maybe Manuel and Chad you're trying to bring in, which are technology-driven kind of changes, you know, until you get the workflow to change and the workforce to adopt it, and, you know, you still don't have anything, right? We just have a great idea without the value being brought through. So I think, Trevor, you know, all the points you make are interesting. Maybe I'm more on the bit like Manuel on the slightly more like I think this is going to be okay side of it, but I'm not saying they're not real points, because boy are they, because if people don't want to join the industry and it's, you know, probably not as attractive as it used to be when we all joined, then we're also in trouble, right? Because
no, I was exaggerating my point.
No, I know, but it's good.
Effect.
It's good to bring it through, though. I think that's the point I'm making.
But, you know, the fact that I've ended up in this session, I think I think the organisers were struggling to where to put this, because this is normally about technology and equipment and software, and here I am talking about people.
But I think the point,
but it's a side effect.
Yeah,
I think we need to see the side effect, and the side effect of technology is exactly that. And we need to also, that has to be part of the discussion, and that's where I agree with Trevor.
Yeah, and I'm totally with you, Manuel. It's got to come through, because these aren't technology problems. Technology, by and large, we already have. We're struggling to apply it to make the changes. So I also wrote down. I also made a note about the local content thing, Trevor. I think that is gonna be more relevant as we integrate and we bring these, you know, things away into centres of excellence and this type of stuff. I think that is something that's going to be a continuing discussion. And
because there's a few countries, Australia, India, that sort of say the data has to stay in country. And you sort of go, well, in these days of beaming a data,
it's difficult. It's really difficult. Yeah, I do see that, and then I guess, you know, in terms of, you know, that automation journey, you know, that I still believe that we'll come up with new jobs that haven't yet got a job title, but it feels to me that, you know, we're going to see new things come through. So, you know, I can see already there's new jobs that are emerging on the digital side. And the point I wanted to bring up, which you sort of erased, was about how we manage algorithms. So, you know, we have a human resources department, and we all have probably different feelings about human resources, but we need a machine resources department, right? Because algorithms also need to be managed and promoted and demoted, and maybe even, you know, quietly fired because they're no longer useful. And it always gets a bit of a smile or a laugh, because it seems a bit odd to talk about a machine resources department, but I absolutely believe that is something that needs to happen. Now we're beginning to rely on them, and they're becoming business critical. And I think, you know, that sort of journey where it's almost, I've seen that there's a book Accenture published about human plus machine, but, you know, these new sorts of jobs that you need in order to make this predictable, reliable, and part of the system, I think is real, and it's going to become normal in the next 2 or 3 years. But it still gets a smile. I doubt it'll get a smile in a couple of years, because it'll probably be completely normal. But it's part of that same journey about, you know, realizing that the you know, that technical part is going to be just bolted together with our people to get the best out of both bits and make it a fun place to work that you feel like you're really having an impact. So if I go back to you, Chad, I wondered, did you have anything to say maybe a bit more about some of the examples you've got where you were able to enable a client to bring something through they couldn't do otherwise? Because I can see that taking complexity away, and we hear a lot about simplification, and removing some bits you don't need. So integrating the way you've used the camera as a data store, or you know, an encoder, or you know, a host for other sensors. I see all that as being really super positive. I don't know if you had a couple of examples for people who are listening that maybe got them thinking about how they might be able to use it.
Sure. Yeah. Okay. So one example that I did use with the Marine Institute, they so you can send down recording systems on a cable, right? That exists,
Okay.
right? You can buy
Okay.
cheap equipment for that, but what we have enabled there is kind of a streamlined user interface to save time and make it really easy. Where your time at sea is what's expensive,
It is.
and
Yep. Normally.
it's not where you want to be experimenting, right? You need to
True.
experiment in the lab or in the shop, bring it offshore and it work. And what we've been doing for a long time is talking to clients who have already gone through that iteration of, oh, I can do that myself, and then they try and they get it work. It works partly, right? It works good enough sometimes, but a lot of time it actually costs a lot more and takes a lot more time to do that. So what we've really been successful with is helping deliver something. Here you go. This works. It's going to do what you need it to do. Here's your solution to your problem.
Okay. And what about what about the industries you've helped? So obviously oil and gas, mining, maybe.
Not a lot on deep sea mining. We're all
Okay.
underwater,
Yep.
but it's oil and gas, but a
Mainly,
lot of institutions and universities. So oil
Okay.
and gas being what it is, we're servicing that industry through rental market, through
Okay.
a company we work with, Ashted in Aberdeen and worldwide.
Okay.
So we're passively servicing oil and gas and focused on marine science and focused on towards the future for aquaculture and helping police and other people do underwater surveys and studies.
Okay. And then what about we obviously in the UK we have a really big wind sector beginning to build up. Are you working with those guys as well?
Yeah, we are talking. So we are passively again because
Yeah.
everybody in the oil industry is going, okay,
Adjacent.
oil, we can't invest in oil, but what's very, very similar to oil and it's also energy and it also uses the same assets and the same equipment and the same people, wind, right? So you're getting these big investments in wind happening in the UK, Australia, and the United States as a response, I think, to a lot of companies needing something else to target, right? Because you have all of these resources, as Trevor was saying, you can't just let them go. They're experts. They have a lot of people, will we ever have AI that can do a full person's job? I doubt it, right? A lot of people would argue against that.
Would it even be desirable?
No, definitely not, because we're people. We're not machines, right?
So yeah, I sort of and actually, the things that machines are good at and in people, it's kind of like almost vice versa, right? Mm-hmm. So machines are really good at the predictable and the routine, and people are really good when it's ambiguous and you don't really know, right? You have to make a guess. Machine is for if you want to do the same thing over and over again. Yeah. And do it really. Machines are good at that. Right? People are not, right? Yeah. Well, they get bored, right? We're all guilty of it. Yeah. So wind definitely. So okay, so I had one other question as well. So I see one of my children uses these apps, that do these videos where they're sort of time. I can't remember what he calls them now, but they're like time. They're like a stop time video. Where TikTok. Yeah, well, it's not TikTok, but it's okay. Okay, but it's like kind of where you make like a little model and you change. It's kind of like the comic book. Oh, stop motion. Yeah. My kids do that too. Yeah. Yeah. So I was wondering how stop motion has impacted your kind of offering technology, because it's just amazing how much you can do now with these things, right? Totally, yeah. So that's a big part of why you would script, right? Why you would script with our systems is to do routine things over long periods of time, or to do things to automate things that you need to do every time, and you want it done the same way every time. So that totally makes sense. The kids understand it. Kids growing up. Yeah, no, honestly, I've heard a lot of this. They'll look at the presentation like this and be like, "Duh," right? I know. I had that feeling when you were talking. And I have to say, I mean, there's tremendous value in these mosaic stills and photogrammetry. Lots of operators have started using this type of technology. I know there's other suppliers out there too. But it has moved the debate along, and it's made things quicker and even just being able to measure between 2 points and not having to go and measure it in real life. You can measure it from your digital twin. Stuff like that is cutting, loads of effort out of it, making the job much easier. So I can see how these incrementally adding these technologies one on top of the other, and we haven't mentioned obviously Wi-Fi, but I think that will come through, and adding lots more sensors and the surveillance coming through, and then linking with these visual technologies.
Yep. And what we're not trying to do is, oh, sorry, Trevor.
I was about to say the low orbit satellites are going to revolutionize data transfer to shore. You know, high bandwidth, low latency. It's going to make a very different world.
Because that must really help with the sorts of work you're trying to do, because you're typically, you know, being difficult to get to places normally, and maybe not near an infrastructure, because you might be supporting exploration or something. So those types of technologies are going to be hugely enabling, right?
Yeah, so what we made the streaming service for was actually for the existing infrastructure for VSATs. You can control the bandwidth and lock it in to work on these remote systems that everyone uses right now. But what the new systems coming in during beta in North America, that just enables more. You just get more bandwidth, so you get better quality video. So then you can do things. You can start recording on the cloud. You can start processing onshore because right now you can see the offshore video, but the quality is not the original encoding quality that you would have offshore. So you still need that twin, digital twin, right? You still need that twin of data offshore that you mirror to onshore. Eventually you won't necessarily need that. You can do it all onshore, but we need to keep the human in it for sure. Be responsible.
So I wonder if there's any other comments or ideas that you guys wanted to share. That's sort of my list done.
Well, I've just noticed that I stopped my presentation at the conclusion slide, and I remembered afterwards there is a slide after that, which is a parting thought. So my parting thought was that 20 years from now, will we laugh that we used to send sensors along pipelines or around structures, because we'll have instrumented the pipelines and the structures so they can tell us what their condition is, rather than us going to have to look at them to find out what their condition is.
Yeah, and I have that idea that that's probably going to be something that maybe doesn't go all the way there, because some of these pipelines obviously are really long, but certainly in the ends, you know, the riser end and the other end, I can imagine that being really important. You know, just, and especially with creeping change and the threats that you maybe didn't think about when it was designed. You know, and adding just a few sensors makes such a difference, you know, in terms of integrity management. The other thing I think it will really do, and is an interesting one, is whether you would design it in a different way. So if you were much more confident that you knew the condition as you were going along, you could, you know, design something that was thinner or leaner or light or whatever it is. You know, and be a bit more reliant on the sensors. Now, obviously, you know, it takes a journey in engineering to get there, but if you know, that might mean that we could have lighter weight footprint on the environment, but also, you know, less cost. And obviously, as soon as you start taking people out of the equation, a lot of those auxiliary systems disappear too, and you end up with, you know, with a much simpler, you know, kind of design and way to operate. And the inherently safe design, you know, naturally would push you that way anyway. So I could see, and I believe that will be helpful to us in order to come back with safer, more environmentally sensitive and cheaper designs that last longer, more reliable or reusable. I see that as being really important, you know, in the future, is, you know, going after the small pools, build something that's, you know, that's not say recycled, but reusable. You could pick it up and use it again. Or
imagine if a jacket actually contacts you when marine growth reaches a certain size. It's
That'd be amazing.
Come and see me.
Yeah, now. Yeah, and that would. But I mean, why not? Why wouldn't you have that? And the rail is a lot further on what they call, you know, like a cognitive asset that you can interact with and like a bit more self-managing. You know, it's driven partly by the way that the contracts work, but just in general, you can see other industries, defence and rail, for example, have gone further and faster on these types of new ways of working, new business models, using technology in a different way, I imagine that we'll be able to do something similar, right?
Mm.
So, Manuel, anything else from you?
No, I would say that we still have a long way to go in terms of machine learning and automation. I don't think the job automation apocalypse is coming.
No, I don't either.
I'm not saying that's the argument, but I'm saying
No.
that argument exists now in the world where
Yeah.
the automation will obviously make a profound change in how jobs are
Yeah.
looked at and how the general population would have income or universal income. That's a completely other discussion. But I think that the message I want to leave is that we need to be sensitive on that change will exist. The change in how people interact with their jobs and specifically in the offshore industry, that change is now, and that change is happening now, and we're forgetting about that change. I think that's important.
All right, no, that's good. Chad, any sort of final closing thoughts from you?
Yeah, sure. So having worked offshore myself, I can tell you there's, it is a hard job, right? And
It is.
I would have loved some, as an ROV pilot in tech, I would have loved some automation of some sort. The variety of work that you do is kind of mind blowing. Sometimes you go from flying an ROV to fixing it to having to do data logging and recording. It's a very, very wide array of tasks. So some automation is definitely welcome. And there's things you forget. There's no way you can, right? So there's definitely some things you would welcome. I think the current downturn is partially related to volume requirements, obviously, right? So in the long term, like there's less people working right now, but in the long term, it's going to recover a bit at least, right? And we're not going to stop using plastic and gasoline and things. So oil is here to stay for many, many years. So we can all, be rest assured with that, or worried about it, depending on your outlook. Automation just makes it safer. Automation just makes it a little easier to work with.
No, I Trevor, any final thoughts from you?
No, I think I've said my piece.
Very good. Well, listen, thank you all for your presentations and such an interesting discussion. I think, times are changing and things, in our industry should continue to change and we'll see that journey get there. So I thank you very much and goodbye to everyone who's going to be watching this in a short while. Thank you.
Thank you.
Thank you.
Have a great day.
Thank you.
Bye.
Bye-bye.
Thanks, folks.
Bye.